In this video, we're going to see a few different ways of talking about the spread of a distribution. The first measure we're going to look at is called the range. The range is pretty simple. It's the maximum value in the data set minus the minimum value in the data set. So for example, if I want to find the range of this data set, first I need to identify what the largest value is. In this data set, it's 14.2. Then I need to identify what the smallest number in the data set is. In this data set, that's 10.3. And then if I subtract those two numbers, I get the range. So 14.2 minus 10.3 is 3.9. The range is a value that's not resistant to outliers, and that should make sense because you're using the maximum value and the minimum value. And so if those two numbers are very far removed from the rest of the data, then they are going to have a significant effect on the range. So if I add a number that's much higher or much lower than the rest of the data, then that's going to change what the range is significantly. So the next measure that we're going to look at concentrates on the middle of the data, and so this is going to be something that's going to be resistant to outliers. And first we need to talk about quartiles. Quartiles are values that frame the middle 50% of the data. So when we find the median, what we're doing is we're dividing the data set into two parts with an equal number of values in each part. So we have 50% of the data below the median and 50% of the data above the median. The quartiles do the same thing with the lower half of the data and the upper half of the data. So looking at this picture, I see that Q1, 25% of the data is below Q1, 25% of the data is between Q1 and the median, which is also sometimes known as Q2. 25% of the data is between the median and Q3, and 25% of the data is above Q3. So we're dividing the data into four parts with an equal number of values in each part. So if we take our value for Q3 and our value for Q1, and we do Q3 minus Q1, that gives us what's called the interquartile range. So the range is the maximum value minus the minimum value. Interquartile range is Q3 minus Q1. So it's sort of like the range of the middle 50% of the data. So we're going to calculate some examples here. We have this data set of students and how many siblings they have. These are their responses. And we're going to calculate mean, median, range, Q1, Q3, and IQR. So some of this will be review from the section on center. Mean and median are both measures of center. So to calculate the mean, I'm going to add the data values and divide by how many there are, which is 10. If I add these numbers up, I should get 22. And 22 divided by 10 equals 2.2. Now, to calculate the median, first I need to put the values in order from least to greatest. So we have 0, and then we have 4 ones, a 2, 2 threes, a 4, and a 6. And then I'm going to use the crossing off method to get to the middle. And in the middle there are two values, a 1 and a 2. So I need to take the average, or add them and divide by 2. And that gives me a median of 1.5. The range, the highest value in the data set is 6, and the lowest value is 0. So the range is 6 minus 0, which is 6. Now to find Q1, I'm going to look at the median of the lower half of the data set. So I'm going to divide my data set into two equal halves. Each half will have 5 values in it. So the lower half is 0 and 4 ones. And finding the median of that data set, the median is 1. So Q1 is 1. Q3, I'm going to do the same thing with the upper half of the data, 2, 3, 3, 4, and 6. Use the crossing off method, and I get Q3 value of 3. Now, the book talks about some different methods for calculating the quartiles. It talks about the Tukey method and the method that TI-83 calculators use, and then it mentions that software programs will sometimes have different methods. So just kind of be aware that, for example, if you put this data set into Minitab, it's going to give you a different value of Q3 because it's using a different process. It shouldn't really be an issue for anything that we do in this class, just kind of be aware that there's slightly different methods for calculating the quartiles that can result in slightly different answers. So lastly, I'm going to calculate the IQR, which is going to be Q3 minus Q1. Q3 is 3, Q1 is 1, so the IQR is equal to 2. 3 minus 1. So we have another measure of spread, which is called the standard deviation, and we're not going to calculate this by hand. We will be using this value calculated from Minitab. Standard deviation takes into account how far each value is from the mean. And the way that it's calculated, it involves subtracting each data value from the mean, squaring data values, adding them up, dividing, and then taking the square root. So it's really a lot of steps, which is why we're not going to do it by hand. We're just going to use Minitab. But just to be aware of, that's another measure for calculating how spread apart the data is. Another way to think about it is that it's telling us the average distance from the mean for each point. So looking at these 4 data sets, we have one data set where all the values are 50. We have 47, 48, 49, 51, 52, 53, 20, 30, 40, 60, 70, 80, and 0, 0, 0, 100, 100, 100. All of these 4 data sets have a mean of 50. However, they're very different. And so we want to think about how the value of the standard deviation would match with these data sets. So standard deviation measures how spread apart the data are. If the standard deviation is small, that means that they're not very far spread apart. And the data set that is the least spread apart is number 1. Because the data values are all the same. And if the data values are all the same, then the standard deviation is going to be 0. Because there is no spread in the data. Lower values of standard deviation means that the data is not very spread apart. Higher values of standard deviation means that the data values are very spread apart. And looking at these data sets, the most spread apart set of data is number 4. Those are the values that are the furthest apart from each other. So that's going to have the largest standard deviation. And then quickly we're going to mention something that's in section 3.5. We want to use the median and the IQR if we have a shape that is skewed right or skewed left. So if the histogram is skewed to one side, then the median and the IQR are better measures of center and spread. And we talked earlier about how the mean is affected by the tail, and so in order to avoid our conclusions being affected by a few outliers, we want to use the median instead. And we use the IQR when we use the median. If the shape of the histogram or distribution is unimodal and symmetric, then we would use the mean and the standard deviation. So keep that in mind when you're doing the homework.